In math, the group of numbers that can be expressed as a fraction are called rational. So a rational expression is rational, which means that it can be written as a fraction, and it contains variables. Or one variable. In particular, rational expressions many times include a variable in the denominator. To simplify, we'll factor the numerator and also the denominator, and then find excluded values, which would make the denominator 0. These are also referred to as values that make your expression undefined. And then we'll reduce the fraction by separating out common factors. It's important to note that you can never divide by 0. This goes along with finding the excluded values. Okay, so I have a few examples here that will simplify, starting with example 1. For this one, I have 10n squared, and I'll factor this. This may also be called expand. I'll expand the numerator and also the denominator. 10n squared factored is 2 times 5, and n times n. When I expand the denominator, I have 2 times 6 times n times n. I could further factor 6 into 2 times 3. However, in this case, that's not helpful. Oh, I wrote 2 n's down here. Whoops, sorry. That's not useful because I'm looking for common factors in the numerator and the denominator so that I can rearrange and write this as a 1. I can write this as 2 over 2 times n over n, and then write what's left, which would be 5n over 6. Before I simplify these factors and write a reduced fraction, I need to make sure that the denominator is never 0. So I determine which values are excluded. When I look at the factors in the denominator, I have 2, and I don't want that to be 0. And I have 6, and 6 can't be 0, and n can't be 0. None of these values, any of the factors that I have here, are allowed to be equal to 0. I'm not concerned that 2 is equal to 0. 2 is equal to 2, so that's not a problem. 6 is not equal to 0, so that's not a problem either. But n could be equal to 0. So this is what I'm excluding. I need to make sure n is never equal to 0. Now I can reduce my fraction. So these simplify to 1, and I'm left with 5n over 6. This is equivalent to the original expression, as long as I make sure that n is not equal to 0. Many times this is written this way. Here's another example. I have a numerator and a denominator, this looks quite a bit more complicated, but the process is the same. I'll factor the numerator. My numerator is 2x squared minus 9x plus 10. When I'm factoring, the first thing I do is look for a common factor, the greatest common factor. When I combine each of these terms, there isn't a common factor. But always check that first. Then I make it a habit to express my polynomial in standard form. Standard form for quadratic is ax squared plus bx plus c. Standard form would always be a polynomial that is in order by degree, decreasing in order of degree. So I'll write the x squared and then the x and then the degree 0 with no x. There's several strategies for factoring this. One that always works is to use factoring by grouping, where I replace the middle term with two terms. The goal is I will rewrite this 3-term polynomial as a 4-term polynomial. To determine what to replace the negative 9x with, I make a factors and sums table. I need factors of a times c. A is 2, c is 10, so a times c is 20. And there are several numbers that you can multiply together in combination to get 20. My limiting factor, my limiting decision is that the factors that I choose also have to be added to get this negative 9x, the middle term. So when you multiply numbers and you get a positive number, but you add them and get a negative number, that only happens when both of the numbers are negative. So I'll have some negative number times another negative number that multiplies to be 20, and I'll add the two negative numbers to get negative 9. And so I'll choose negative 4 times negative 5. Because negative 4 minus 5 is equal to negative 9. So I can rewrite this polynomial as 2x squared minus 4x minus 5x plus 10. And I just exchanged out the middle. Then I split the polynomial in half, and I look for greatest common factor for just the first two terms. And that would be 2x. If I factor out 2x, that leaves me x minus 2. When I compare the second two terms, the greatest common factor is negative 5. And when I factor out negative 5, I have negative 5 times x minus 2. Now I look for a greatest common factor for the whole polynomial, and I find that when I look at this as a whole, that both the first group and the second group have an x minus 2. And then I can make a group by undistributing x minus 2 and writing what's left, which is 2x minus 5. And if you multiply these back together, then you should it'll return back to the original unfactored polynomial. So I can write this numerator as x minus 2 times 2x minus 5. This is equivalent. I also need to factor the denominator. When I factor the denominator, let me get this set up over here. I want to rewrite this in standard form, which is in order by degree. Sorry. So I'll write negative 9x to the third power plus 9x squared plus 18x. Then I look for a greatest common factor. For this polynomial, my greatest common factor is negative 9x. And once that's factored out, I have x squared minus x minus 2. And you can use any strategy that you like to factor x squared minus x minus 2, but we continue factoring until we have negative, ooh, that's frustrating. Negative 9x times x minus 2 times x plus 1. So this is equivalent as a factored form of my denominator. So I can write that here as well. My goal is to reduce the fraction. I also need to make sure that my denominator is never equal to 0. So I need to determine what values should be excluded. So for these three terms, I'll exclude exclude negative 9x equal to 0. Also, x minus 2 equals 0 should be excluded, and x plus 1 equals 0. When I solve these three simple equations, I find that negative 9x equals 0 when x is equal to 0. And x minus 2 equals 0 is true when x is 2. And x plus 1 is equal to 0 is true when x equals negative 1. So these are my three excluded values. Okay, so now I know what to exclude from my solutions, and I will rearrange this this factored fraction over here where I have more space. I'll stack up the matching factors so that I can write this with as many ones as possible. That's how I will go about reducing my fraction. Here's what I mean. I have an x minus 2 in the numerator, and I have an x minus 2 in the denominator. So if I write this as x minus 2 over x minus 2 and separate those factors from the rest of the factors, then I have x minus 2 over x minus 2, which is 1. And 2x minus 5 is remaining in the numerator. And in the denominator, I have negative 9x times x plus 1. This is equivalent to the original rational expression, as long as I do not allow x to be 0, 2, or -1. So this is reduced.